Hello and welcome back to this van conversion series. Please like and subscribe to our channel so that you don't miss an episode. We'll be following our conversion of a Citroen Relay L3H2 week by week, so if you missed last week's video you can see it in the link here. Hello everyone, week 7 of the conversion and really good progress last week. You can see, looking in the van, the ceiling is up. So last week we did all the slats which look really nice. Obviously just got the lights on, all that circuit's all hooked up now. We've got all the worktops in, so all the window sills around the living space, above the boiler unit, and obviously the kitchen unit is now installed, that's secured. So this week we're going to be really focusing on the utilities and sort of the finishing touches for the cabinetry, getting all of the cupboard fronts, the overheads, the wardrobes and kitchen unit installed with their final coat of paint and the handles and hinges put on. Also need to get the electrical cupboard, which is going to be in this box here, all connected up with the 12-volt circuits, the 240 circuits and all of the charging systems as well. Once that's installed, we'll then get the final box seat in the back, secure that all in place and get the hinges for the lids all made and put in. So yeah, look forward to what's to come and we should have a good week. I'm working on some of the electrical compartments now, and you can see we've obviously got the Sergeant control panel here, that's installed. That also has the water level gauge and the water pump relay attached to it, so you can turn all that on from this control panel. The main light switch for the van is obviously next to that, so you can access these when standing outside the door. You can turn the lights on. In the upper cabinets, in this one here, we're going to have a bit of boxing in, and that's going to house the Truma combi control panel, the LPG solenoid, so you can switch the gas on and off and check the levels of your LPG up in this little control panel up here. What else is there going to be? We're going to have the battery monitor, so the Victron BMV712, which will give you your battery capacity in a percentage and also how long you can last off grid. And we've also got a power supply for a couple of LED downlighters, which we've put the hole saws here underneath. So we've got 2 in the kitchen unit. These are 60mm hole saws and they're going to be touch sensitive LED lights. You can see one of them's installed here, and to turn them on and off you just touch the bezel and they'll come on and off. So they're 12 volt. Really happy with those as a product, and it lights up the kitchen unit really nicely. So what I'll do is I'll take one of the power inputs up here for the lights, and then I'll just wire those 2 touch lights in. What we do as well is we just run a bit of 6mm plywood, just so that we when the cables are sort of stuck down to the baseboard, we then put another bit of white plastic over the top of those, so all the cables and the top of the light is hidden. So it will just look like a white bit of plastic sheeting over the top of that. So I'll show you that as it goes on. So I've connected the cables up to the supply. You can see this blue black cable here is the supply, and just connected up the lights. I've also just temporarily fixed the cable onto the battery, and what I do is I choose these Wago connections with an inline fuse just to protect the cable, just a 2 amp fuse in there, just to test the circuit before I put the white plastic on the base. And then all you do is touch the bezel and it switches these on, and these are actually dimmable, so if you hold the bezel it dims the light as well, so you can just adjust them like this. So they're really good, but we like to have them underneath the kitchen unit because it just lights up the space whilst you're doing your food prep. I'm working in the Truma boiler compartment. You can see the boiler there, and what I'm actually wiring up is the fused spur, which is going to be, when you're an electronic hookup, you can switch this on here and you can run the Truma combi boiler off of your mains electric. To do this, obviously we've got 2 cables. One's coming from the Truma itself, which is the output, and then the supply is obviously coming from the RCD and the circuit breakers, so via the hookup. That's in there. What we like to do is use ferrule crimps, which are like bootlace crimps, just so that you can get a good termination into the terminals here. You can see on the back of the fused spur, you've got the supply, which is obviously the Arctic blue cable coming from the hookup, and then you've got the load, which is going to the Truma, which is the flex cable that comes out of the unit. I'm working on the electrical cupboard. You can see I've run some of the cables. They're going to go into the battery compartment with the power supply unit and all the chargers and the inverter. And what I've done is I've just run a negative cable, which is going to go onto a bus bar. So this negative here, go from the negative on the batteries, and it will run onto this negative bus bar here. And then all the 12-volt negatives will connect onto this bus bar. This will be boxed in, but it will still have access just by a couple of screws on the screw cap. Just if there's any electrical faults in the future, it's good to have access to where the connections are made. So this is the negative bus bar. The positive bus bar is going to be in the battery compartment as well, with the fuses. And then obviously this negative bus bar, the main negative continues, and we connect that to the vehicle chassis. What I like to use is one that is a manufacturer's earth. So this is in the rear brake light pillar on the near side. You can see obviously the wiring loom for the vehicle is connected or terminated on this sort of earth here to the chassis. This is the earth that's attached to the power supply unit, so I'll connect that onto the chassis of the vehicle. This is the 16mm cable, which will connect the negative from the battery onto the chassis of the vehicle as well. So I'll make that connection now, and then essentially connect all of the 12-volt circuit negatives onto this bus bar. So I'm now connecting the positives and negatives to both the bus bar, which is here, and that goes obviously to the negative of the shunt on the battery, and then the positives is obviously all the 2-core that runs into the circuits of the van, all come to this point, and then the positive of that 2-core I then connect onto the wiring loom that comes out of the Sargent power supply unit. So this one, for example, is for the Truma control panel. I'm connecting the positive onto the yellow and the brown cable, and then the negative I'm connecting onto the screw termination on the bus bar. And what I'll do is for all sort of 11 or 12 of these circuits, I'll connect them onto a different positive that corresponds to the fuse board on the Sargent power supply unit. And some of these have specific jobs. So for example, the purple cable is for the water pump, and so I'll make sure I connect the water pump positive onto that cable, and that essentially is controlled via a switch that exists on the control panel to turn on the water pump. So we'll just make sure that we connect those all up now using some spade crimps, and then I'll show you what we're doing next. So I'm just cutting the boxing in for the area above the negative bus bar, and I've oversized this top piece a little bit because I'm going to flush trim that back with my router to give it a nice round over. I've scribed it into position, and what I'm going to use now is a bit of mitre bond so that I can have an instant grab between the two pieces of timber. So I'll put a bit of mitre bond, which is essentially super glue, all along this edge, and then on the other edge where they're going to join, I put the second compound, which is the pen. You can get this as a spray, but essentially I'll mark on the where it's going to be, and as soon as these two products make contact, it gives an instant bond. So I'll just apply some pressure, and then they'll be stuck together. I'll then give it a bit of mechanical fixing as well, just by whacking in a couple of brad nails to make sure that it's all secure. Here's the piece of boxing in. It's now mitre bonded together, and you can see I've got an overhang. Just cut it slightly too long so that I can use a flush trim router to bring that nice and flush. And what I'm going to use is a 1/4 inch round over bit, and it's this ball bearing here that runs along the piece underneath to bring it flush together once we complete the joint. I'm starting to connect up some of these cables in the battery compartment. And you can see I've got the MPPT here, which is the solar charge controller, or the MPPT, and underneath that I've just got the cables run from the panels. So I've got the solar negative here and the solar positive here. These are running 6mm solar cable. Solar cable is specific for any cable that's sort of on the outside of the van, so attaching to the solar panel. Really it's important because it's got UV protection properties, so you wouldn't want to use sort of normal flex cable up on the roof for your solar panels. It's also tinned copper in terms of its core, which is a better sort of material. It's more durable and will last a bit longer. And then essentially it's got two cores essentially to protect it from wear and tear. The inner core is like this opaque plasticky insulation, and then the outer core is a slightly more flexible black rubber insulation. So yeah, you've got to obviously strip both those insulated cores to get to the conductor. And I'm just now going to put a ring terminal on here, and this is the isolation switch that I use just before the MPPT, so that if you want to isolate the solar panel and don't want to use it for whatever reason, you can press this button here and it will disconnect the positive conductor. Just looking into the electrical compartment here, you can see I've started to put the chargers in. So this is the DC-DC and the MPPT. I've obviously wired in that MPPT isolation, and then here I'm just connecting the bus bars and the fuses onto the battery. You can see we're connecting these 100 amp hour batteries into parallel, so positive connected to positive, and then the negative will be connected to the negative there. I'm running this bus bar onto the positive via a main fuse, and this is a resettable fuse, so that can be used as a main switch as well, just to isolate all circuits. It's rated at 80 amps, and we're going to be running an inverter connected onto this terminal here, and that won't be pulling anything more than sort of 800 watts. So chargers, laptops, things like that. The positive bus bar is a 4-way bus bar. It comes with a top cover which will sit on there when all the connections are made. And what I've got is these strip link or MIDI link fuse holders. You can see this one here is for a DC-DC charger, so I'll connect the DC-DC charger positive onto here, and this is a 40 amp strip link. So the fuse is rated to protect the cable. The cable is going to be run in 10mm flex, which is rated at 70 amps. So if there is a short circuit, this 40 amp fuse will blow before the 70 amp cable begins to melt. So protecting the cable. And again, this is the MPPT charger rated at 40 amps and the mains charger rated at 40 amps. So I'll run all of those to the chargers in 10mm, and then off of this terminal here we're going to run the 12 volt circuits via a 20 amp fuse, and that will be a blade fuse. And then we'll also run the compressor fridge off of this as well, so it's got its own circuit and its own 20 amp fuse, and we'll probably run that in 6mm cable. To make the door for the shower cubicle, we take an internal plywood door that you can purchase from places such as Howden's. It's really lightweight because it's got a hollow core, but it's lined with 6mm plywood. It's 2 foot wide, which is the same width as we make the door lining, so you don't have to rip it down at all or use a plane to make the door narrower. But we do need to cut the door to the height. So essentially what we're going to do is use a plunge saw to cut this to the right height, which is 1/64, and then essentially we'll just take the batten which sits in this end piece and then just reuse that to fix it to the bits of plywood which line the outside of the door. So we've made that cut, and you can see the top's been sawn off, but what we need to do is now replace the batten that was essentially going to go here. So this will now be the new top of the door. You can see this interior is like egg box cardboard. It's really hollow, but it's like structured so that this is nice and strong, so it doesn't give way at all. But it's a nice lightweight door. So you can see it's got 6mm veneers, and then it's got this batten which is the structure, and everything gets glued and clamped onto this batten. So we're just going to replace the batten in here, and then obviously we're going to have the door the correct size. So we're going to take this piece and we're just going to rip on the table saw 24mm off of the top, which will give us this batten here, and then we'll just chop off the bits of 6mm on the sides as well. So, and then we'll insert that glue and pin it in place. Here's the batten ripped down after being on the table saw, and you can see it just slots in there nicely. And before we put this in fully, we'll just put some wood glue on these edges and clamp it in place to let it go off. And then yeah, that batten's then been replaced. And we've got a door at the correct size for our shower cubicle. Next step is to put in the hardware, so the door handle, latch, and also we're going to router some grooves just to give this door a bit more character before we prime it and paint it and hang it up ready to go. To give the door a bit of character, we're using a router, a trim router with a core box bit inserted. And what we look to do is just create some grooves on the door to give it some shape on the verticals and the horizontals. So we've now prepped the door in terms of we've stuck the rear side plastic, which is this 2mm thick white rock material. And on the bottom, we've got this drip here, which will just help any water that runs off it just to not seep underneath the door. And it will go onto that step and down into the shower tray. We've cut a hole in the bottom, which is going to have a vent mounted on it. And we've just used a trim router bit just to cut this bit of plastic flush to the lined hole on the inside. So there'll be a vent that goes on top here. We still need to cut the door handle and fit that, but I'll show you the other side because we've painted that and grooved it. I'll show you what that looks like now. Starting to fit the shower door now, and the worktops are getting installed. We've got the touch sensitive downlights in above the kitchen unit. So Stuart's just working on the cupboard fronts, just getting them all lined up before we install them for good. And so here you can see the blum hinges we use, and here are the Phillips screws that you just turn to adjust the hinges. They can go any direction, so up or down, in and out, and that helps to line everything up nicely. You see here's obviously where we've cut the blum to fit the hinge. That's a 35mm sort of drill bit that goes in, and this will be obviously pantry drawer sliders that will come out. So Stuart's just getting the overhead cupboards in. You can see these have got the hinges that are spring loaded, so they stay up themselves. We're just using the flange head screws just on there so we can look nice. You can see here the cupboard fronts without the handles, and then we've also been installing the handles. These are from IKEA, really like them, a nice smart look and go well with the white cupboard fronts. And all the drawer sliders have also been fitted, and these have all got soft close sliders on them. So this is a large cutlery drawer, and that just shuts nicely there. Stuart's just putting the piano hinge onto one of the seat box lids. You can see these ones here have obviously been fitted, just waiting for their handles to be put in. But yeah, they fold down and allow access to the garage space. You can see this is the piano hinge once it's in position, and we'll put some gas struts also on these box lids just to help it stand upright when you lift it up. Something we like to do just to add a really nice finishing touch is we use a sealant on where the joins are in the van. So you can see this bit here is nice and sealed up using some Fix-All. And to prep it nicely, we tape the area and just leave a couple of mil just so the sealant can sit within those areas. We'll put a bead onto that now, and then we'll work it with some fairy liquid and water to lubricate it so that when you use your finger, it gets nice and smooth finish. So yeah, we'll apply that to plenty of areas on the van where there's a join between two bits of timber, and it just gives it a nice finish. We've obviously got the floor installed, which is the LVT flooring that we like. And then we also add this piece of beading along the edges because there is an expansion gap, so we leave about 5mm of an expansion gap just for different temperatures. It allows this to expand and contract, and then we just overlay that with a bit of beading, which we then nail into position and paint. So there you have it. All that's left to do is to give everything a good clean and get the soft furnishing in and a little touch up everywhere. We hope you found this van conversion series useful, where we broke down the 7 weeks of the build into 7 episodes. You can see the full van tour when it's finished in the link here. And if you haven't done so already, please like and subscribe our content, and we'll see you next time. Thank you.